Hello there guys, welcome to this video, and in this video we'll be looking at the validity of probability function. We are still solving questions on all that we have done so far, so please stay tuned as we solve these questions. So as we solve the questions, before we begin, kindly pause, solve it on your own, and then you come back and do it along to see or test your understanding. The question is, determine whether each of the following function can serve as a probability mass function of a discrete random variable. Now you have to remember the conditions that a function can serve as a probability mass function. The first one being that all of its, when you evaluate all the values, all the random variables, you should get a number which is 0 or greater than 0. The evaluation of the function should be greater than 0. And then secondly, if you add up all the values, the distinct values of the variables, you should get an answer which is equal to 1. So let's quickly take a look at how we are going to go about this. For this first question here, it says f of x is giving us what? 2 into bracket x minus 2, where x takes values 1, 2, 3, and then 4. So we can start solving by first solving for f of 1. So we are testing for two conditions. First off, f of x should be greater than or equal to 0. That means it shouldn't be a negative. So even as we are starting with this, if we get only one value that is even negative, that ends it. There is no need even solving again. All right, so let's take a careful look at that. For the first one, we are solving for f of 1. We already know what this function is, 2 into bracket x minus 2. So it means anywhere you see your x, put 1 over there. So you have 2 into bracket, instead of x, we are going to put what? 1. You see, so you are going to put 1 there, then minus 2. Evaluating, we have what? 2 times 1 minus 2 gives us a negative 1. And if we multiply that, what are we going to get? So 2 times negative 1 gives us negative 2. This here is a red flag. We are getting a negative answer. You see, so far as we are getting a negative answer, there is even no need to continue, because the condition was the evaluation of the function should give you an answer which is greater than or equal to 0. The first one doesn't even satisfy, so hence there is no need. This function here is not worthy of being a probability mass function. So we can go to the next one. That is our conclusion. This function cannot be a probability mass function. So let's look at the next one. The next one here says f of x is equal to 1 all over 2x minus 1. And we have to test if this function can be a probability mass function. So once again, we are testing for f of x being greater than or equal to 0. So we start with f of 1. That is substituting the value of x when it's 1. We have 1 all over 2, then our x becomes times 1, then minus 1. Evaluating this, we have 1 over 2 times 1 gives us 2, minus 1. And this alone should give us 1 on 1, which is equal to 1. The first value has passed. Let's go to the second value. So we have f of 2. That is 1 all over 2 into bracket, so 2 into bracket our 2, then minus the 1. Evaluating it, we have 1 or all over 4 minus 1, and that should give us a 1 over 3. The second value has also passed. Then we test the third value as well. We have f of 3. So we have 1 all over 2 into bracket our x value, which is what? 3. Then minus 1. should give us 1 over 2 times 3 gives us 6 minus 1, which gives us 1 on 5. All these are passing, so let's check the last one as well. So the last one is for what? F of 4. And using the same function, we have 1 all over 2 into bracket our x value, which is 4, then minus 1. Evaluating, we have 1 over 8 minus 1, and 8 minus 1 gives us a what? A 7. So we have been able to test, and all has passed the first one, that is, they are all greater than 0 or equal to 0. At least they are all greater than 0. The second condition is that we are to make sure f of 1 plus, or in short it says the summation of f of x, right? So for I equals 1 till your nth should be equal to 1. It means, what all this means is we are adding f of 1 to f of 2 to f of 3 and then to f of 4, and at the end of the day we should make sure we get 1. If not, then it can't be a probability mass function. So let's add our values. We had 1. Oh well, as you can even see, the first value alone is equal to 1. The first value alone is equal to 1. Hence, adding the rest would even make it worse. So, assuming it even came to our mind earlier, we should have been cautioned here that we are getting a 1. Hence, the remaining can't satisfy. You see, so we are adding 1 to 1 over 3 to 1 over 5 and then 1 over 7. That is, we are adding 1 to 1 over 3 to 1 over 5. And then 1 over 7. Right? This alone over here is a red flag. It is 1. Hence, we are going to get an answer which is far, far greater than what? 1. Hence, equation function 2 can also not be a probability mass function. So let's take a look at the third one also. Now, this one says g of x equals 1 on 5x. And we have to determine whether or not it can also be a probability mass function. So we start our test just as we did for the previous ones. So we have g of 0, and g of 0 gives us 1 over 5 times 0. This alone gives us infinity. But we are saying it should be greater than or equal to 1. This giving us infinity here, at the end of the day, just as the previous one, if you are going to add all of this, then it means we are going to get a very, very huge number. Hence, this can also not be a probability mass function. I hope you are understanding. There are 2 conditions. The first one is that we should evaluate all, and we should make sure they are all greater than or equal to 0. The second one says if we add everything, you should give us a sum of 1. You see, well, this evaluated here has given us a number which is greater than 0. But if we are to test them all out and then add, this alone here is giving us a number which is greater than 0. So if we are to add, even if these ones are giving us decimals, our final answer will still be greater than 0. Hence, there's no need continuing. We can conclude by saying g of x cannot be a what? A probability mass function. Right? Cannot be g of x. Right? Then we go to the next one. We have h of x. So we have h of x. H of x being equal to 1 over 16 into bracket 5 minus x squared. The same procedure. We start with our 0. Starting with our 0, we have h of 0. That gives us 1 on 16, then into bracket 5 minus 0 squared. Simplifying this gives us 1 over 16 times 5, which is a 5 on 16. H of, sorry, not h, but then h of 2, of 1. I do hope you understand all this. So let me just write the answers so that we test and see if they satisfy, right, for time's sake. Or without even solving it, or let me rather take the 3. Let's solve for the 3. So that is h of 3 is equal to 1 on 16, then into bracket 5 minus 3 squared. That gives us 1 on 16 into bracket 5 minus 9. You see? So 5 minus 9 we know gives us a negative 4. And if we evaluate this, we have negative 4 on 16. This alone is a negative number, a red flag. Alright, so it's quite unfortunate that all the functions we considered here can't be probability mass functions, but the condition remains constant. First of all, each and every random variable should give us a number that is greater than what? That is greater than or equal to 0. Should be greater than or equal to 0. And secondly, after evaluating all these values, we should find the sum of the individual values. The sum should always give us a number that is what? Equal to 1. If these conditions are not satisfied, the function cannot be a probability mass function. Thank you for coming to this end or coming to this part of the video. Now there's a part where I ask that if the video was useful or was beneficial to you, kindly subscribe and then share, and always let me know at the comment section what you would want me to do to help you become better at maths. Thank you very much and have a blessed day. Bye.